Our sneak in. England. Okay, so I guess we're going to have a smaller than usual class, unless something happens. I can't seem to get this thing to turn on, which is not deadly, but make sure the cables are properly. Which cable does this thing want? Got it? I don't know. Okay. I'm going to bring us back to something that happened Tuesday. I left something out. And if you did as I suggested and went home and did a problem, you might have figured it out or you might not have. But I'd like to fill in. Not so much because it's real important that you get this time around. If you go on, take some higher level physics courses, or you take the differential equations course, you're going to run into this and you'll get it the right way. But and let me just put up one set of initial conditions. So if you go through the procedure I described, you would say, well, the roots are r squared plus 4r plus 5 equals 0. This is the associated polynomial. And then you went to solve this, you'd say, okay, negative 4 plus or minus the square root of 20 minus 16 over 2, which is negative 2 plus or minus I. There are two roots. And they're complex roots. Now, you could just kind of go forward with what I told you, and you might be able to make progress. You could say, well, y could equal e to the minus 2 plus I x. Let's just deal with this one first. And you'd say, well, wait a minute. You know, times some constants. Doesn't really matter. We're going to be moving constants around for a little bit. But that's what? That's a e to the minus 2x times e to the ix. And I kind of hinted at this, but I didn't really explain this very well. You need a formula, which again I believe it's Euler's formula. It says e to the ix equals I sine x plus cosine x. So this would become a e to the minus 2x times I sine x plus cosine x. And that would be one of the solutions. The other solution would be, which, you know, again, these are still linear, so it's a linear combination. It's still e to the minus 2x, but here we have e to the minus x. So that would be minus I sine x plus cosine x, because cosine is even and sine is odd. So now we're still looking for a and b. So if we plug in 0, y of 0, we get a here. This becomes 1. This becomes 0. This becomes 1. So it's just a. Here we have b. This becomes 1. This becomes 0. This becomes 1. So we have a plus b equals a half. Now we have to find the derivative of this, right? Okay, so that's not something it's not something all that pleasant, but we'll do it anyway. So we have a times negative 2 e to the minus 2x times, this is going to be ghastly, I sine x plus cosine x plus, using the product rule, a times e to the minus 2x times the derivative of what's in here. Okay, so that's going to be I cosine x minus sine of x plus, now I have to find the derivative of this. This is y prime, right? So I've got b, again, negative 2e to the minus 2x times minus I sine x plus cosine x plus e to the minus 2x. Now the derivative of this, so that's going to be minus I cosine x plus sine of x. Okay, so what we're hoping is that we'll plug in, we'll use this information to find another equation in A and B. Right? So here goes nothing. Y prime of 0. Well, this is negative 2a. This is 1. This is 0. This is 1. Good. Plus, here we have a. This is 1. This is I. This is 0. Plus negative 2b. This is 1. This is 0. This is 1. Plus b times negative I. Oh, well, seen better looking stuff, but negative 2 plus I times a plus negative 2 minus I times b, and that's equal to 1. All right. So I'm not going to finish this because I'm lazy. But I've got two equations and two unknowns, A and B. It's complex, but hey, we've done complex numbers. So that's how you deal with this. I might add, since, well, I don't know how this is going to drop out, but you're clearly, what you're getting here now, you're getting an exponential function times a sinusoidal function. Right? I think actually that's just worth looking at. you sciencey types, or science wannabe types. If you had a function y of x equals e to the x, or e to the minus x, I think by now you would know that it's either kind of like this, or it's like this. Exponential decay or exponentially increasing. If, on the other hand, you had y of x equals e to the ix, well, that's a sinusoid, right? That's sine or cosine or something. So what happens when you have these two together? Well, when you multiply them together, clearly you're going to get one of two things that's going to happen. Either you're going to get something that starts very small and gets larger and larger. And as an example, if you have, say, a pendulum, right, and it's going back and forth, and every time it goes back and forth, you give it a little bit more push at the same frequency as the pendulum, right? What happens? Well, it starts swinging higher and higher and wilder, and eventually something bad's going to happen. Oh, darn, I can't make this work. This would be a perfect opportunity. Oh, computer? Is that it? There's a famous bridge in New York over the Carquinez Strait. I'm sure some of you have seen it, the movie of it, where this bridge was, pushed at its resonant frequency, and you see in the movie, you just see it fall up. A big suspension bridge, like the Golden Gate, except smaller than the Golden Gate, and it just, the wind comes up and it just knocks it down. So that can happen. The other thing that can happen is if you've got a minus e to the minus x, you have something that's, it's sinusoidal, but it's being damped. And then, it kind of goes to zero. You can't really see it anymore. And what I think is interesting is that damping all seems to be related to this this extra term here. I could be wrong about that. I haven't investigated it enough, but it looks that way. I mean, if you just have a second degree and the function, you're going to get either a sinusoid like I think you're going to get a sinusoid like this. And if it's just a first degree, you're going to get an exponential. Just when you have both of them, you put it together. So, all right. I just thought this was neat stuff. You don't have to sweat it. You're not going to see anything like this on the final or on the quiz. But again, I thought this was fun stuff. All right. Let me just check now. Is Ed here? Cedric? Jiahao? Chen? Kenneth Wong? Kim? Oh, Melanie, you're here. Ning is here. You saw her. Chris? Chris, okay. Let's see. And then just showed up. Let's see. Art is not here. Frank? Frank's not here. Jiahao? Oh, yeah, you're here. Okay. Andrew? Andrew's not here. Go away. Richie? No Richie. And Yumao? Here. Oh. Oh, and Zibit. Oh, here. All right. Couple quick orders of business. Reminder, there will be a quiz on Tuesday. will be a quiz. The following week, there will be on Tuesday the final exam. I don't anticipate a problem with doing the quiz on Tuesday and me getting it back to you Thursday. But hopefully that won't be a problem. A reminder about the final exam. As per the rules of this school, I'm required to see a picture ID. Now, I'm sure that, I've never had an issue where someone couldn't show me a picture ID, but hopefully that's not an issue. Does anybody have a problem bringing a picture ID? You all know why that is, don't you? I mean, some students have gone to great lengths to get a good grade in a class, including paying someone else to take the class for them. That just doesn't make any sense to me. But, so it is. Okay. Are there everybody who turned in homework? Let's see. 1, 2, 3, 4. Just because I hate bringing paper home. Are there any questions on any homework or on the worksheet from Tuesday or on the worksheet from any other day? Make sure the cables are properly connected. I really want this thing to work because I want to show you something from the web. But I don't seem to be able to get these things here to do anything. All right. Okay. You don't have video. Big screens work if we don't. So we're going to backtrack a little to a subject that I have little mixed emotions about. The mixed emotions have to do with technology. I all know you all have calculators. You don't have to take them out yet. You all know how to punch in a function and how to get an approximate definite integral out. And that's actually been true for many years now. It hasn't always been true. So you kind of have approximate integration at your fingertips. You don't have a calculator, maybe you have a computer system. You can even go on the web now. You can go places and just type in a function and it will do the integration for you. So what today is we're going to look at how that is done. It's interesting. There's a little bit to it. Most of you will not ever have a situation where you need to know this, but there are circumstances where this is really useful. I mentioned before this very classic statistics function or integral. We want negative x squared dx. This function kind of looks like this. It's the bell curve. And when we're doing statistics, we sometimes want to find the area under it. So again, you can use your calculator to do that. You might be doing an experiment. For example, I don't know, maybe as a professor who once hired me once did, you go down to the beach and you put a pole in the beach with a float and you hook that up to a kind of a recorder thing and you collect data points for the waves. And all you have is numbers. You don't have a function. You're looking for a function, and maybe you want to find the area under, whatever curve this is. Right? So you might need some of this. Maybe you're interested in computer programming, and somebody someday asks you to write an algorithm or some code to do this. So, okay, so that's the justification for this. It's a little tenuous, but it's there. So, first thing we're going to look at is a very, very simple strategy. We have some function, and we want to do an approximate integration on it. That is not an exact integration. We want to do a numerical integration. And this may look like something we did at the beginning of the class, talking about Riemann sums, but we might break our function up into some fixed pieces with a fixed delta x, right? And when we were doing Riemann sums, typically we would take, the initial point and do a rectangle. A rectangle like here and here, and here, here, and so forth. We're going to do something, and we could do it on the left or on the right. We're going to do something a little smarter. We're going to take the midpoint. In other words, we're going to take the function in the middle of each of these intervals. And we're going to sum up the rectangle for each of these intervals. So we want some kind of formula for that. So if we think of each of these points as being like x0, x1, x2, and so forth up to x to the n. So what would the midpoint be? The midpoint is the average of x sub I plus x sub I plus 1 over 2. That's this point here. And we want the function evaluated at that point. And we want to multiply by delta x. That will give us the area in one of these rectangles. And then we want to sum over each of these. I guess we should go from 0 to n minus 1. where n is the number of intervals. I'm sorry, n is the number of points. N minus 1 is the number of intervals. And you can even take a further step. See, delta x is clearly, it's x of n minus x of 0 over n minus 1. And one nice thing about this formula is, because this is a constant, we can bring it out front. So we're doing our computer calculation. We don't have to find this and multiply each time. We just sum up these function values. Now this is called the midpoint rule. And it's a pretty basic way to do an approximate integration. It does have a disadvantage. The disadvantage is in the case where I was describing, where you just have some data points, you don't really know what the value of your function is between those points. So it doesn't work, you could make one of these points your data point, but then you're integrating from someplace to someplace where you don't really know what the value is. Well, I guess that's how it goes. In any case, that's the disadvantage of the midpoint rule. You don't know the function, and you're trying to integrate it, it doesn't work. So, as an alternative, see if I can draw exactly the same picture here. Yep, there it is, exactly the same. We can try a different strategy, which is called the trapezoidal rule. So again, we break our function up into intervals. But now instead of taking the midpoint and doing a rectangle, we take the two endpoints and create a trapezoid. Now, just to be clear, a trapezoid, four-sided polygon, where one set of sides are parallel. Right? So these are your parallel sides. Okay, so again, we'll label these points x1, x2, x3, so forth. So the area of a trapezoid, these are like delta x's. The area of a trapezoid is the length of these two sides. So that would be f of x of I plus f of x of I plus 1. Times delta x, but divided by 2. Does everyone call that what? I find it easier to kind of look at it this way. So if this is height, is length 1, length 2, it's just length 1 plus length 2 times the height over 2. Is the area inside the trapezoid. All right, and as before, we want to sum this. from I equals 0 to minus 1. And again, since delta x is fixed, we can move it outside the sum, which simplifies our calculation a little. So we have the midpoint rule and the trapezoidal rule. So we want to look at an example of these. This kind of example is a little tedious because it's just adding up a bunch of numbers. But I think doing it once, seeing how it works, probably worthwhile. It's also the case that if you're really serious about getting any kind of accuracy, you're going to make delta x very, very small. Right? We've got computers now that make delta x small enough. We're going to look at how small in a minute, but to make delta x small enough that that we get an accurate answer. But I'm not going to do that on the board. So because that would take all class period and learn very little. All right. I want to take the integral from 2 to 10 of x squared dx, and I just want to use 4 subintervals. So I'm starting at 2 and I'm going to 10, right? And so my midpoints are going to be at 3, 5, 7, and 9. That's what xi plus 1 over 2 is, 3, 5, 7, 9. And my delta x is 2. Right? There are 4 points, 2 times 4 is 8, and I'm going from 2 to 10, which is a distance of 8. And so my sum is just going to be 2 times, well, the function at each of these points. So 9 plus 25 plus 49 plus 81. And that added and multiplied out turns out to be 288. Okay, that's my rough estimate of the area. Oh, this is the wrong curve, but just imagine x squared. It's going up very quickly. All right, let me repeat that calculation over here. So now, the points I'm going to deal with are what? 2, 4, 6, 8, and 10. The function at each of these is 4, 16, 36, 6400. And I'm going to take the average of each of these. So the average of 20 is 10, plus the average of 52 is 'Hm. I just thought of something. I'm going to save myself some trouble here. My delta x is 2, right? So I want 2 squared plus 4 squared over 2 plus 4 squared plus 6 squared over 2 plus 6 squared, 8 squared over 2, 8 squared plus 10 squared over 2. So in this case, my 2's cancel. And I just have to add these up. 4 plus 16 plus 16 plus 36. I told you it was a little tedious, right? 64 plus 64 plus 100, which equals 336. Okay. So we get different approximate answers. We're not using a very small delta x anyway. And we clearly have some kind of error here. In this particular case, we can find out what the exact answer is very easily, right? We know how to do this. This is just going to be x cubed evaluated between 10 and 2 over 3. So this is 1,000 minus 8. It's 992 over 3, which is approximately 330 and 6 repeat. So this has an error of what, about 42? Absolute error of 42, but over 330, this is about what? This is about 13%. Now this guy, he's only about 6 over 330, or he's just a little less than 2%. This is absolute error. I'm sorry, this is relative error as opposed to the absolute error. Okay, so this is a good example of showing you something that'll give you the wrong idea. Because if I said, which of these do you think is more accurate in general, you might be tempted to think the trapezoidal rule. It even kind of looks like, maybe it's following the curve a little better. It's true if the curve is going down, you get, a little excess and a little whatever. But it turns out that this is actually a mistake. In fact, on average, the midpoint rule will be twice, the accuracy will be twice as good. I'm going to show you some formulas that you can find in the book. You don't need to remember them. You don't need to put them on your cheat sheet. Just take a look at them now. All right? So, supposing you can bound the derivative of the function, you can say it's plus or minus the derivatives between some value k. Well, the error of the midpoint, the absolute value of the midpoint, has to lie between k times, let me rephrase that. It's bounded by k on some interval. So k times the length of that interval divided by 24 n squared, n being the number of intervals you break it up into. So you can see, the wider the range of the derivative, the more the error can vary. The bigger the interval, the more the error can vary. The larger the number of intervals, the smaller the error can be. So this is for the midpoint, E sub m, that's for the midpoint rule. For the trapezoidal rule, A similar analysis shows that it has to be less than k times e minus a over 12n squared. Does anyone want the door open? Because I'm actually getting chilly. Yes, thank you. So it turns out that, strangely enough, the trapezoidal rule is not quite as good as the midpoint rule. Again, something you might be concerned with if you're writing a computer program or you're just analyzing some data. Okay. Do a little planning here. Okay. What we're going to do now is something we haven't really done. I'm really going to encourage you to get together, find a little group of people. 2 people, 3 people, I don't know. I want you to work together because, again, this is a little tedious. We'll break up the work. And, we're just going to take a look at what the results are. So, what we're going to do, we're going to take 2 integrals, and we're going to apply the midpoint rule and the trapezoidal rule. Yes, I'll get this out of the way. And we're going to come up with some values. All right? We're going to start on it now. In about 10 minutes, we'll go on a break, and then we'll come back. And we still need more time. A little more time. If you want to work on your own, that's okay. You definitely will want to pull out your calculator. And don't worry too much about how many decimal places this needs to be. It's kind of a So on the left, you'll see there 2 different integrals, and there's a little chart to fill out. You can fill out the exact value however you want. Either find an antiderivative and use your calculator, or just use your calculator.
What?
And then I want you to...
Do you have extra?
Hey, can you be quiet, please? We're trying to work over there.
I will return.
After what?
Extra liquid coffee.
No? Just ask him.
Dude, I moved here after we got
And if you want to move your chairs around a little bit, that's okay.
That's why I didn't get in. I didn't get in either.
Okay.
Good. I don't want to check. If I didn't get in there, that means like...
Who else did I stiff here?
I'm done here. You're done.
Okay.
See Riverside?
Oh,
I wasn't like 2 days. Wait, maybe I didn't even apply that. I don't know.
Is everyone clear on what I want you to do with these? One more?
Sometimes it doesn't.
No.
I
I thought I heard one more.
Yeah, no, for sure. Hey, you ready for Santa Cruz? Join us at 3 a.m. I got to wake up at 3 a.m. Haha, staying up. Then you're gonna let us. Hey, whoa! Don't look at my password. You're gonna go hang out with your. Dude, I hang out with that guy all the time. What? I go up there all the time.
Really?
Not really.
You hang out with your roommate Chris?
No, I actually never hung out with Chris. I don't even know if
I don't think
I
you UC Riverside.
don't think I applied to UC Riverside. Oh no, I did.
You wrote them all down to the list?
Yeah.
I haven't even logged into half the schools.
Can you get started on this, by the way? Where's the portal? And how do you know?
Wait, how do you do this?
No, okay, so you put this
Oh, you're
in,
live?
put this into the calculator?
See his Twitter.
Yeah, wait,
Yeah,
just
wait.
have that. How,
Show it to
I can't even find the portal.
Just Google it. Takes 2
Don't say-
seconds.
Look, I'm a CS major. You don't have to tell me how to use a computer, okay?
And now, when you can't find it. You probably got it.
No, I don't have half the classes, I'm pretty sure.
Let's give them some time to process the results.
Where is it supposed to be? It said check your social media. Let us know if your email changed. My alerts. No, I have no alerts to worry about right now. Thank God. Make sure to check your My Alerts and My Announcements test about your admission status, your messages, yeah, no, I don't have anything. I didn't get in, guys. I'm done, so. Did you get it? How do you know about this shit?
I'm checking college confidential. Some people said they got it.
Well, I'm a transfer for CS. There's no way I get in anywhere. Alright, here, let me do this.
Alright, so Riverside is early March, rolling thereafter.
Yeah, basically rolling for everything. I have a friend that's in the fraternity, that's in the sorority that those 3 guys, those 3 girls got caught in.
Yo, Melly. You know what is it? Davis doesn't even do personal statement.
What the hell?
Santa Cruz doesn't either.
I got only L.
Then why the hell did I write one?
Santa Barbara doesn't do personal statement either.
Oh my god, my personal statement was an inspirational story. It was like, I'm a failure in life, but then I came up from the ashes. It was very inspirational. I'd be exact for this one is 0.785. By the way. Melanie? It's 0.785 to be exact.
Yeah, I know. Thank you.
Well, then why didn't you tell us?
It takes like 2 seconds.
You're like those the athletes that I have to work with. Unbelievable.
Yeah.
There's this one kid. I thought he was a freshman because he's so slow. Like not speed-wise, but like mentally he's slow. So when some kid comes up to me and he's like, "Oh, he's a senior," I'm like, "Wait, what?" I was like, "What the hell?" Okay, you play too much football, man.
Maybe he's special ed.
He's not. I can tell who is and who's not. This guy is not.
If he's slow. We're about to beat them now.
We have not received a high school transcript. That's because you didn't ask for one. Dick.
Which one?
UCR. I don't know. Please send all their complete final official transcripts. Send their official. Alright, yeah, I don't give a shit. July 1st. Yeah, whatever. Alright, midpoint roll. Did you start it? What is the midpoints from 0 to 1? So that's 0, 0.2, 0.4.
Yo, can we just like look around?
No, you can't. Whoa, what's happening? What's happening? Alright. Yeah, I bet you I can get the answer faster. Are you doing midpoint yet? Dude, I'm already halfway there. I'm already halfway there. Alright, 0.786. Did you get 0.786 for the midpoint? Well, that's because I did the faster thing.
Well, that's how many you want to break it into.
No, the only shortcut is you just keep pressing enter. You change the number. Look at that. Or I just use the answer, whatever, plus y1. I just did that.
There's a reason X is measuring the Y.
I'm doing the midpoint rule, bro.
Well, 5 intervals
Get
is
wrecked.
better than 4, but I just want 5 points, so 4.
Alright, trapezoidal rule.
8 intervals. 8 intervals. The number n is the number of points, so the number of intervals is 1 less than that. So it'll be 4 intervals and 8 intervals. 4 intervals, but n points. Number of data points. Exactly.
0, 1
Between 0 and 1.
Come on, Melanie, it's not that hard.
That's a secret that you'll learn later. No, we're going to. I just want you to do midpoint and trapezoid. On your calculator?
Melanie, I just told you, it's not that hard.
Wait, how do you just put the midpoint, right? And then you plug it into the height. And you add it?
You might be able to, probably program it to do that, but it'd probably take you longer to program it than to just add up 4 intervals. You're really right on target. Do you understand? We're just doing an exercise, but of course, if you can program it, you wouldn't use 4 intervals or 8. You'd use 1,000 and 10,000, right? So we're just, this is a monotonous.
Alright, I got
boring
0.73
exercise
for the
that you must
trapezoid.
go through. You must suffer. Because in life, sometimes you have to suffer.
Come on, Melanie, it's not that hard.
To appreciate how well you have.
Do you understand how to do midpoint?
You find the midpoint.
You find the height of the midpoint.
Yeah.
And you multiply it by base. Right? So you're finding the rectangle.
Yeah,
So the difference is 0.2.
yeah.
Then you add them each together.
I know.
Dude, I don't know, man. I think you're doing something wrong.
You can't afford to do that.
Yeah? Okay, I remember this machine now. Alright. Yeah, I'm not about to flip this down. I'm not about that life. It's actually not that bad.
Here. Are you applying to Foothill? Where do you want it?
What's happening? Whoa, my butt just...
Wait, how do you do the freaking thing? Okay, what is exact?
Exactly, just the integral.
And there's a ton of schools.
Isn't this in this one?
No.
What is it?
Sunshine?
This part?
Exciting. Well, good luck.
And delta
It's
x
too
is
late,
that.
right?
So,
If you wanted, a recommendation.
dude, oh my god.
No, I get what's there.
What do you mean 0.4? The answer is 0.78.
I know.
Okay,
It's like,
let me just show you. Dude, it's way wrong. You keep multiplying by 0.2. You multiply the whole thing by 0.2.
All right, so it's 7 o'clock. You can keep working, or you can take a break. Take a break for 5 or 10 minutes, and then we'll come back and we'll look at why are you the results.
Oh my god, I'm gonna kill myself.
Okay, wait, we must.
And if anyone out there thinks that they're smarter than me
Y times point
with computers, which is not saying a lot, and can get this screen up there, it would be really appreciated, because I'm tearing my hair out.
If there's 5 points in this, the intervals are 0.5, 0.4, 0.8, the midpoints of those intervals are 0.1, 0.5. No, and you're also using fractions. You've got to put reasons. Yeah, I'm so sorry. There's some people who just say, I didn't recognize him, but he recognized me, and he was like, hey, are you Kevin? Yeah, and he was like, oh, what are you doing here? I was like, you know David Moll?
No? Who is he? Who's David? Wait.
Who's Homestead High School had no parties?
Wait, who are you talking about?
Didn't go to any parties, so I don't know how you can claim this.
Wait, who are you talking about?
David Moll.
How do you even spell his last name?
M-O-L-L.
I didn't even know he
You
existed.
can turn it off.
He goes to UCSD.
No, he's not even on Facebook.
I'm sure he is. I'm just an idiot.
No wonder why I've never heard of this person.
Dude, you haven't heard of a lot of people. You live under a rock. Yo, he's right here. Lajala.
Mole?
Yeah.
I said MU.
What the? Are you an? I said, oh.
What the hell? He has 150 mutual friends. How can you never heard of this?
He has 264 mutual friends.
Wait.
Nice. When you figure out the Simpsons rule, can you just do it for me? Because I don't want to do it. Bro, Simpson is nuts.
Let's see if,
Yes. Trapezoid is easy mode. Here, I'm just gonna go to paulsonlinenotes.com for all your calculus 2 needs.
yes, you may not like the extra credit. It might be in the form of, chocolate goods or something, but I will get you some kind of credit.
Whoa, extra credit. I heard that. Oh yeah, I gotta ask him what's on. Do you know what's on the test next week?
Probably different.
Shut up with these lies.
Yo, is this on the test?
I'm gonna have to ask you to calm down.
Okay. That seems good enough.
Where is it? Yo, I can't find it.
Okay.
I want to sleep so badly.
No. Oh, whoopsies! I bookmarked this. I don't want to bookmark it. Riemann sine. Riemann.
Okay. Let's see.
Now it's in calculus 1. Now Simpson's rule is hell easy. It's just very tedious. All of these are very easy and slash tedious. Oh, is this what we're doing? Wait, is it break?
Yeah.
You know what sections we're going to do on the quiz next week?
Oh, I need to tell people that. Yes. So, let's see. $7.5. $7.6. Well, there could be a question from 7.7, since that's what we're doing today. 7.8, and 7.9. Everything. 10. I mean, there's no way I can cover everything you've done, so it will be a sampling.
Do you think it's going to be curved?
It's exactly the way it says in my green sheet. There will be curves on it, though. Definitely. There'll definitely be curves. That's correct. That's correct. On analysis, you actually have the opposite. You can have curves that the closer you get, the worse they look. No. But I throw away your worst. Right? Yes. And I don't grade like, oh, you got it wrong. I look at what you did, so I do give partial credit. Sounds good. Thanks. I actually appreciate feedback on the question of fairness. Like if I did something and someone thought that was unfair, I would like to hear fair. That's my goal, is to be fair. Okay. Ming, did you have a question?
Yes, I want to ask how many questions will be covered on the final exam?
I don't know yet. I told Kevin I'm guessing around 10.
Okay.
It's the whole period.
Okay.
2 hours and 15 minutes plus, people need a little time to finish up. Nobody can make me go home. So, but it will cover the entire, from the beginning of the class, it could be anything that we've studied.
You still stuck on this point?
No, I figured it out. I'm the
Sorry?
Alright, well when you figure it out, let me know.
Will I tell you exactly which problems?
So it starts with...
I will give you I'm planning to bring in on Tuesday kind of a review sheet to say these subjects. Okay?
Basically, find
Stuck in. I wasn't looking.
parabolas. You're basically turning the...
Oh, that's no good.
Yeah, you're turning it into a
Really bad.
between each one. That's how you do. And you're basically finding the average of the area of the average of the parabola. So you're finding like integrals on integrals. Right? ERD. No, I'm not going to that. I'm not like you. I don't stick. Oh, wait. I got tired.
And you did this.
Let me correct something I said, Kevin. I'm not sure yet, but it's conceivable I might put an extra credit problem on the exam. That would be completely optional and unnecessary. Don't be shocked.
Yeah.
Okay, so Frank is here and Kim is here. Everybody else? Cedric?
Here.
He's here. Yeah, okay.
You're almost done.
He's not here. Andrew? Richie? Not here. Okay.
So you split the interval from 0 to 1 to 5 words, right? Whereas 1 to total.
do n minus 1. That's what original assault.
Oh, really?
Just remember original. If you do this, it's going to 1, 2, 3, 4, 5. Too many.
No, it's not right.
So what does that mean, right? Because it says right here that n minus 1 is the non-meaningful. We're asking us to do
Yes. 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 N is the number of data points, so the number of intervals in this one.
Oh, data point. So if I go to 5, data point. Yeah, so okay, you just keep plugging in like in between the intervals. Out of the heights and 11.25.
So yeah.
Wait, what? Okay, so
Tell me what answer you. Tell me what answer you. So I'm getting a different answer from you guys, so I'm like, why am I getting a different answer?
maybe you did it right.
Maybe I did it wrong too. If I were you, I definitely would.
Okay, I got 0.6. It's hard on. No, I think. What'd you get?
625?
Oh.
Wait.
Okay, let me just ask, is everyone, has everyone had a chance to get your hands dirty with this? All right. Does anyone have some numbers for the first integral for the midpoint and the trapezoid? Anybody? No?
That's my.
It's funny, sometimes students like look right at you when you ask a question, and then sometimes they look away. Nobody even has the first one. Okay. All right, well.
Did you do it wrong? You have to do intervals of, there has to be 4 intervals, because you're using 0.2.
All right, let's
Use n minus 1.
I'm going to leave this here.
Because the data points is
Another
1.
blackboard, blackboard over there.
And use 0.25 for this one. You were using 0.2, right?
Yeah.
It's supposed to use 0.25. There's always supposed to be 4.
Okay.
N is the number of data points. The number of intervals.
Time for show and tell.
How do you get the my one into the screen? No, how do you get my one on?
So for the first integral, 0 to 1. So I need 5 points. So the first point is 1. The last one is 0. I mean 0, 1.
7.9.
So what are these going to be?
You said there's extra credit.
What?
0.25,
After you left.
0.5, and
And I'm not
0.75.
lying.
And I was like, shit, do you think they did that credit?
Yeah.
And
Ask
then the
anybody in the class.
function
You can ask the boss.
at each of
I
these
literally
points
called
is
you out,
what?
Kevin. I just remembered something.
So
Like after
this
you left,
is
like
0.
I even
I mean,
messaged
this
you on
is
Facebook
1.
about it, like 3 minutes, 5 minutes ago.
This is 1
Maybe a
half.
minute after you left.
And this is 1 over
Alright, guess you don't want extra
3 quarters, so it's 4 thirds. And then 1 over 3 halves, so it's 2 thirds. And then 1 and 3 quarters is 7 quarters, or 4 over 7. So you'll notice on the screen, this is a web page you can get to through my site, and I've already plugged in trapezoid interval 0 to 1, n equals 5. I just need to put in some numbers. So the first number is 1. And the second number is, I can do that in my head, 1.33333. Doesn't have to be that accurate.
Yeah, that sheet.
Wait a minute, that's not right.
That sheet just ring 2 calculators.
I can't, right? Can it?
I don't have that type of money to buy a
See,
hundred on the calculator.
Just borrow.
1 1/4 is 5
Share this thing already.
quarters, oh, 4/5. Is that right? No? All right. 1 over 1 plus 1/4 is 5/4 or 4/5. That's right. What about this one? 1 plus 3 quarters is 7/4, 4/7. Yeah, that's right. Okay. So 4/5 is what? That's just 0.2.
I got it.
I don't know if I did the right thing here yet, but we'll kind of go with it for a second. 6, 6, 6, 7. Number 4 is 4/7. Is that right? Yeah. 1 4. What's 4/7? 5/7 is 5.5714. And then the fifth point is 0.5. 0.5. So now, I hope and pray, please enter a valid value. 0.2. What happened here? Uh-oh. I guess my little grand, something went wrong with the program here. Just try one. Probably going to fail again.
Dude, San Jose State's really trying to get me to come to their school. I received like 5 different emails from them and like 3 different packages from them. So I'm not going. I just applied just to make sure. Cover all my bases.
Oh, how rotten. Oh, I know I think I know how to fix this. Use a different browser. Okay.
Trapezoid.
Just take,
Imagine
Seems maybe that
Imagine you're finding the trapezoid on its side. Okay.
this is right there.
thinks that
It doesn't save it.
You just find two heights, okay? You find the average and multiply by the.
You find the height of the left side and the height of the right side. How do you find the height of a trapezoid? How do you find the area of a trapezoid? Base 1 plus base 2 times height divided by 2. Right?
Is it actually?
What? That's how you find it. So you imagine the left side is 1 base and the right side is 1 base, and the height is the distance between the 2 bases. which is your interval distance. And you divide that by 2. Boom. You just found trapezoid. Congratulations.
1, 2, 3, 4, 5 points.
Here, okay.
Well, this is really tough. I'm doing trapezoid.
I'm surprised that you got a higher grade than me on the last quiz, to be honest.
They're better than studying.
Yeah, he got
This guy got like an F. Studying.
I did not study.
Okay, so,
I did.
this just shows you how crazy technology can be. So here's the HTML, for those of you who know what HTML is for this code. And for Chrome, if I say the type is a number, it wants an integer. So get rid of Chrome.
Just make it a double.
But
Just make it a double.
with Safari, either it ignored it or it doesn't care. Now, as just explained to me, I'm putting in the wrong values because I forgot that it's 1 plus x squared. Does someone want to give me these points? I know the first one is 1. Does anyone want to tell me what the values of these points are? Or should I enter them myself? All right, I will enter them myself. 1 divided by 1 plus 0.25 squared, 0.9, 0.9 for 117. Okay. And 1 divided by 1 plus 0.5 squared is 0.8. Are you going to give me the other two numbers? 0.64. And what's the last one? 0.5. Is that right? Right. 1 divided by 1 plus 0.5 squared is, well, that's 0.8. I apologize here. How can that be? Oh, well, 1 plus 1 divided by 1.
Yeah.
1 plus 0.75 squared. That's 0.64. Oh. Of course it's 0.5. Okay. So my question is, did anybody get a number like, for the trapezoid rule, 0.7827, something like that? Anyone? I guess I should put my little chart here.
Yeah. If you can.
Okay, so this was, N is 5, and midpoint trap and 0.7, let's say 0.78. Does anyone have a number for the midpoint? My calculator doesn't do the midpoint. All right. All right. Does anyone have the trapezoid for n equals 9?
I only have it. You have it, don't you?
How about the exact value? What's the exact value? Don't make me do this. .7853. Okay, and did anyone do the midpoint? Anyone get the midpoint?
Well, I did do it, but then I got it wrong.
Point.
Yeah, first one.
I only wrote 2 decimals.
I only wrote 3 decimal points. I only wrote 3 decimal points.
That's okay. 0.7, what?
8-7?
0.7,
I got
8,
8.6.
7.
I got 8.6.
I think it's 8.
We just crashed the rocket.
8, 6.
6-7.
All right. Well, look, you can kind of see,
Always right.
not that this proves anything, but the midpoint actually is closer to the exact value than the trapezoid. Did anyone do this for 9? Anyone?
0.7856.
0.7, is this
Midpoint, yeah.
0.78?
56.
Ah, it looks a little better, right? I realize this is an obvious kind of lesson, but the bigger n is, the better your answer will be. Of course, you know, to get this down to 10 or 15 places, n might have to be 100,000, in which case you won't want to do it by hand, right? You will want some help, yeah, program, right. Okay. All right, now's the part of the lesson where I do a bait and I show you that I've been doing a bait and switch all along. Right? You'll notice on this calculator thing here, somebody asked me about what's Simpson. I'm just going to click Simpson, and I'm going to click calculate, and I get 0.78539. It's over here, Simpson. 0.78539. Well, that actually looks better than all the other ones. That looks like it might be better than the midpoint. Right? So what is this mysterious Simpson? Before I go into what it is, it might be nice to know relative to the midpoint of the trapezoid what you get for your Simpson. The Simpson error, using the same conditions, bounded by k on an interval a to b, is less than or equal to k b minus a to the fifth over 180 n to the fourth. That is to say, a lot better. Actually, I don't know if this 5 really belongs here. I don't think it does. This is a much more accurate way of doing things, and I haven't even told you what it is. Okay. So now's the part, I guess, right? So I have to sacrifice something here. I think I'm going to sacrifice the midpoint. We haven't memorized it already. It's in the book. Okay. So what we do with the Simpson rule Simpson's rule, I don't know his first name. is we approximate the curve here as the area between 2 points on a parabola. It's kind of hard to draw this without, right? So each of these curves between these points is a fitted parabola. Now, I guess I actually drew that wrong, because instead of doing it this way, what I have to do is I have to take 3 points, right? And I fit a parabola to those 3 points. Which means I need a 1, 2, 3, 4, 5, 6. Which means I need an odd number of points. I'm just going to remind you of something from your geometry days. Does anyone know how many points you need to determine a circle?
4.
Close, but incorrect.
3.
3, right? Yes. 3 non-collinear points, unless you're doing projective geometry, in which case a line is a circle, but that's neither here nor there. If you have 3 points, you can draw their perpendicular bisectors, find the center, and that determines one circle. It turns out this is also true of any other conic you might think of. So if you have 3 points, there's an ellipse that goes through this. Is that right? And there's a single parabola that goes through it. So this is adequate. The next question, of course, is what is the formula for Simpson's rule, right? So the formula looks like this. F of x sub I plus 4, f of x sub I plus 1, plus f of x sub I plus 2, divided by 3 times delta x. So that's the area of one of these sections. And you can kind of see why this would be more accurate, because now instead of a line, you're fitting a curve to the function. And then, of course, here we have from I equals 0 to n minus 2, but, you know, I don't know what we have for a summation, but in programming we say plus equals 2, or plus equals, yeah, you have to jump from here to here to here each time. So, okay, that looks awfully simple, doesn't it? And as a final, kind of a final piece of technical knowledge from approximate integration, we're going to look at why this is so. All right? Let me turn this off. Okay. Yes. Let's take a look at this problem. Right. So we're going to start with a somewhat simplified version of the problem. We're going to take a parabola which is nicely centered on an axis, and we're going to take 3 points. Points being h, minus h, and 0. So this parabola goes through f of minus h, f of 0, and f of h. And what we want to do is we want to figure out what the equation of this parabola is. We're going to describe it as y equals ax squared plus bx plus c, which we know that's going to be a parabola. So the area under here can be described as the integral negative h to h, here to here, right, of ax squared plus bx plus c and we're going to break this up into 2 integrals, negative h to h of ax squared plus c and negative h to h of bx. Well, if you take a look at this function, it's what kind of function? Ax squared plus c. I'm doing this a lot lately. It's a certain kind of function that when you're integrating from minus h to h, turns out pretty nice, right? It's an even function. So we can write that as 2 times the integral from 0 to h of ax squared plus c. Now, this function here is not an even function. It's another kind of function. What kind of function is this? Odd. And when you integrate from minus h to h of an odd function, you get 0. Okay. All right, let's go through this. This is 2 times ax cubed over 3 plus cx from 0 to h, or 2 times ah cubed over 3 plus ch, or if I take out the h's, it's h over 3 2ah squared plus 6c. Did I do that right? Yeah, 6c. Okay. So I want you to look now at what happens when we add the following. F minus h plus 4 times f of 0 plus f of h. All right. I guess there's f of x, right? Can't really keep that on the board at the same time, can I? Okay, well, So if I plug in negative h there, I get, from here I get AH squared minus BH plus C plus well, now I'm plugging in 0, so I just get plus 4C. Right? And then I plug in H, and I get plus AH squared plus BH plus C. Okay, so the BH's cancel, and I get 2AH squared plus 6C. So if I multiply this quantity, what am I multiplying this quantity by? Oh, well, I'm going to multiply this quantity by h over 3. That's my formula, right? Now I have what Simpson's rule. Now I have what Simpson's rule calculates, right? But that's just what I found out is the area. So that tells me, at least in this one case where I have the parabola nicely lined up at 0 between h, minus h and h, that Simpson's rule gives me the area. But of course, if I shift this, right, just if I do a linear translation on it, the area doesn't change. I feel like there's a little hand waving here. But that's why Simpson's rule works. So. Okay. Quarter of 8. Way too fast. Comment about homework. When this class was originally going to be scheduled, we had a quiz that took the whole period. And then some people went ahead and did the homework. So if you did that, and I passed it back to you and said not assigned, and you kept it, you can hand it in whenever you want, and I'll give you credit for it. If you haven't done it, and you do want to do it, you are welcome to use the online calculator instead of going through all the numbers. And if you don't want to do it, that's okay too. Any questions? That's all I have for tonight. I'll stick around and see if there's anything else we need to go over.
What about the quiz?
The quiz will cover sections 7.5 through 7.9. I would expect a partial fractions problem. I would expect a improper integral. I'd expect a simple differential equation problem. There might be a simple numerical integration problem. Oh, no, nothing about that. No, absolutely not. Say what?